Dear friends, in this video lecture, we will see one more very important property of a liquid at rest, that is surface tension. You will see that the drop of rain coming down always acquires a shape of a sphere. The raindrop is always spherical in shape. Though the density of a needle is more than that of water, the needle which is coated with a wax can float on the water surface. An ant can walk on the water surface, and fly can sit on the water surface or the liquid surface. It is all because of a property which is possessed by a liquid surface, that is called as the surface tension. Here we are going to study in much more detail about the surface tension, why there is a surface tension, what is the effect of surface tension, and what are the factors on which the surface tension depends on. आपल्या रोजच्या जीवनामध्ये आपल्याला पाहायला मिळतं की आपण जेव्हा दाढीचं ब्लेड त्या फोम मधून काढून पाण्यावर जर अलगद ठेवलं तर दाढीची ब्लेड पाण्यावर तरंगू शकते. खरं तर दाढीची ब्लेड ही लोखंडापासून बनलेली आहे. लोखंडाची डेन्सिटी पाण्यापेक्षा जास्त आहे. ज्याची डेन्सिटी जास्त आहे ती वस्तू पाण्यामध्ये बुडाली पाहिजे, हा नियम आहे. पण असं होत नाही. त्याचं कारण असं की लिक्विडमध्ये एक विशिष्ट प्रॉपर्टी आहे ज्याच्यामुळे लिक्विडवर मुंगी चालू शकते, माशी बसू शकते, दाढीची ब्लेड तरंगू शकते. हे सगळं ज्याच्यामुळे होतं ते सरफेस टेन्शन आहे. त्याचा आपल्याला अभ्यास करायचा आहे. Before to start with what do you mean by the surface tension, one should remember every liquid surface behaves as if it is a stretched membrane. ताणलेल्या पापुद्र्यासारखं आहे ते. जसं डफलीवर कातडं ताणून स्ट्रेच करून बसवलं जातं तसं लिक्विड सरफेस हे ताणलेल्या पापुद्र्यासारखं आहे. एव्हरी लिक्विड सरफेस बिहेव्स लाईक अ स्ट्रेच्ड मेम्ब्रेन. व्हाय इट इज सो? इट कॅन बी स्टडीड विथ द हेल्प ऑफ the molecular theory. And before to start with why there is a surface tension, we will see the molecular theory. What is molecular theory and what are the different terms involved in a molecular theory? For that we will start with intermolecular force. Every substance is supposed to be consist of large number of molecules. Molecules of the same substance possesses the same property as that of the substance. The molecules of a substance exert a force on each other. The force is always a force of attraction. This force is inversely proportional to the distance. As the distance between the molecules increases, the force of attraction between the molecules decreases. With increase in distance, there is a decrease in intermolecular force. Broadly, intermolecular force is of two types. One is the cohesive force, the force of attraction between the molecules of a same substance is called as cohesive force, and the phenomenon of attraction is called as cohesion. Wood molecule attract a wood molecule, that is cohesion, and the force is the cohesive force. Water molecule attracts the water molecule. It is a cohesion. The force of attraction is the cohesive force. Attraction between the molecules of different substance is called as adhesion, and the force of attraction between the molecules of different substances is called as the adhesive force. The force of attraction between the water molecule and the glass molecule is the adhesive force. The attraction between the wood molecule and the iron molecule, that is the adhesion, and the force of attraction is the adhesive force. Then this intermolecular force of attraction is possible within a very small distance. This intermolecular force is neither gravitational nor electromagnetic. It is different one, and it is a short range force. This intermolecular force of attraction is a short range force. It is possible within a distance of few nanometers. It is of the order of 10 to the power of -9 meter. The maximum distance measured from the center of molecules up to which this intermolecular force of attraction is possible, that is called as range of molecular attraction. With molecule as the center and range of molecular attraction as the radius, if we draw an imaginary sphere, this imaginary sphere is called as the sphere of influence. For the molecule A, R is the range of molecular attraction, and a sphere of influence with radius R, range of molecular attraction, is called as sphere of influence. And any another molecule which is within the sphere of influence is able to experience a force. Therefore, molecules within the sphere of influence are able to exert force on the molecule which is at the center. Then the distance from the surface within which the molecule has the sphere of influence is called as the surface film. Surface film is a film which is having a thickness which is equal to a range of molecular attraction. A surface film is a film having a thickness equal to range of molecular attraction from the surface. And the free surface of a liquid, the surface which is exposed to air, the uppermost surface which is exposed to air or any other matter is called as the free surface of a liquid. Therefore, I will write here xy as the free surface of a liquid and x dash y dash. The x dash y dash is another line, a film between x to x dash and y to y dash. This film is the surface film. Why the liquid surfaces possesses the property of surface tension? It can be explained on the basis of molecular theory. What is that? For that, let us consider there is a container filled with a liquid. Let A is the molecule of a liquid which is well within the liquid inside the container. This is the molecule A. A is the molecule of a liquid. It is well within the liquid inside the container. Draw an imaginary sphere of influence for this molecule A. The whole of the sphere of influence of molecule A is within the liquid and it contains of molecules of a same liquid. Therefore, all the molecules within the sphere of influence exert a cohesive force on molecule A in all directions. All the molecules within the sphere of influence exert cohesive force on molecule in all possible directions, and because of that the resultant force acting on molecule A is equal to 0. Resultant force on molecule A is equal to 0. Let us consider B is the molecule which is close to the surface of the liquid and it is within a surface film. B is the molecule within a surface film. Therefore, if you draw an imaginary sphere of influence for this molecule B, you will see that its major of the portion of the sphere of influence is inside the liquid and very little of it is outside the liquid in air. Therefore, the measure of the sphere of influence of molecule B contains the liquid molecules which pulls the molecule B downward, and the molecule in the upper part of the sphere of influence exert a force in a upward direction, but the resultant of cohesive force in a downward direction is more than that of adhesive force. Therefore, molecule B, not molecule B, but all the molecules like B are acted by downward force. Therefore, force on B, not only B, but all the molecules which lies in a surface film are acted by downward force. In a similar manner, we will have a third molecule which is represented by C. C is exactly on the surface of a liquid. C is exactly on the surface of liquid. If you draw an imaginary sphere of influence for molecule C, you will see that exactly half of the sphere of influence is inside the liquid and half is outside the liquid. Therefore, molecule in half of the sphere of influence exert a downward force, and molecules in remaining half of the sphere of influence, that is air molecule, applies a adhesive force in a upward direction, but air molecules are very small in number, adhesive force is negligibly small. Therefore, all the molecules like C are also acted with downward force. Not only A, but all the molecules like A within the liquid which are below this surface film are having a resultant force which is equal to 0. And all the molecule which lies in a thickness equal to range of molecular attraction is called as surface film are acted with downward force. Therefore, all the liquids in this surface film are acted with the downward force called as the downward pull. This is downward pull. And hence liquid on the surface are acted with a downward force, and because of that, if you take a surface of a liquid like this one, this is the cross section of the surface of a liquid, and I will draw an imaginary line on this free surface of a liquid. Let P is the molecule as shown in the figure and Q is this molecule. Rather, I will consider a free surface of a liquid, and on this free surface of a liquid an imaginary line AB is drawn, and this imaginary line AB divides the surface into two parts. One is to the right of the line and other is to the left of the right. line. The molecules on the right of the line are attracted by the molecules which are on the left of the line, and the molecules which are on the left of the line are attracted with molecules on the right of the line. Therefore, the molecule P which is on the right is acted by a force by the remaining molecule which is perpendicular to the line, and similar to that, molecule like Q is acted by a force towards the right. Therefore, all molecules on the right are acted with a force towards the left, and all the molecules to the left are acted with force towards the right. And these molecules, because of their cohesive force of attraction, stretches each other as if they want to tear the surface, and because of that the surface is under the tension, and this is known as the surface tension. In short, all the molecules on the surface are acted by a force because of the liquid surface behaves as if a stretched membrane, and because of that the liquid surface is under this tension, and this tension is known as surface tension. The force on an imaginary line is always perpendicular to the length of the line. Therefore, the force per unit length acting right angle on either side of imaginary line is called as surface tension. Surface tension is defined as a tangential force. Tangential force per unit length acting at right angle on either side of imaginary line drawn on the free surface of a liquid is called as surface tension. Unit of surface tension is obviously Newton per meter, and dimensions of the surface tensions are m1, l0 and t minus 2.